Hello everyone, my name is Gajendra Deshpande. I am working as assistant professor at KLS Gokte Institute of Technology, India. Today I will be delivering a talk on inventing curriculum using Python and spaCy. This project is supported by Google Cloud under GCP Research Credits Program. In today's talk, we are going to discuss about curriculum and introduction, text summarization, then two Python libraries, spaCy and TextC and their features, then our experiment regarding uh, curriculum generation, then finally the conclusion. Let us first have look at few definitions of curriculum which are listed on University Delaware's webpage. Curriculum is nothing but a course of study that will enable the learner to acquire specific knowledge and skills. A curriculum is the combination of instructional practices, learning experiences, and students' performance assessment that are designed to bring out and evaluate the target learning outcomes of a particular course. Curriculum is what the school is attempting to teach, which might include social behaviors as well as content and thinking skills. A selection of information segregated into disciplines and courses typically designed to achieve a specific educational objective. The curriculum is the program of instruction. It should be based on both standards and best practice research. It should be the framework that teachers use to plan instruction for their students. Curriculum can be both written and unwritten. In our work, we are focusing only on written curriculum. We are not focusing on oral or unwritten curriculum because we need data for our project, which is only possible through written curriculum. Now, on this slide, you are seeing the structure of undergraduate engineering programs in India. It's defined by AICTE, that is All India Council for Technical Education, which is the body which defines the structure for uh, engineering education and other professional courses in India, especially the engineering programs. Now, if you see this slide, it's a structure for undergraduate engineering program for computer science students. Now, if you look at this slide here, it includes different types of courses. For example, it has basic science courses, engineering science courses, professional core courses, professional elective courses, then open subjects, then project work, then also the mandatory courses on environmental sciences, then induction program, and so on. So basically, the objective of the program is to uh, prepare students for better career prospects in industry, and it focuses on overall development of a student. Now, this is a sample curriculum for web technologies subject uh, for diploma courses in India. So if you see here, the syllabus content is divided into different units, specifically 5 units. In the first unit, uh, students will study about introduction to World Wide Web. Then in second unit, they will study about the web systems architecture. And from third unit onwards, they are going to study few technologies which will help them to develop web applications. For example, you can see here they are studying JavaScript, they are studying advanced scripting concepts like HTML, CSS, XML, and introduction to web services. And finally, the PHP, which is nothing but the server side programming language. Now, in this slide, you can see here it's a job posting on Indeed website. So, if you look at the description, they have mentioned some keywords which are the desired qualifications and the requirements of the employer. For example, you can see here it is mentioned that UI for the web and mobile applications. But if you compare this with the syllabus, mobile applications is missing. Then similarly, it's also mentioned that the knowledge of jQuery and Bootstrap is appreciated. Again, these things are missing in our syllabus. Then this is another job posting on the same website, indeed.co.in. So here also you can see here they are expecting technology such as again Material UI, React, Angular, Vue or Webpack, and also the knowledge of GitHub. So many things are missing in the syllabus. So basically there is a gap between the syllabus content we teach to the students and the job requirement. So the main objective of our project is to reduce this gap and make the students more employable. Now our project is based on the concept of text summarization. So let us first discuss what is text summarization and different types, and then let's move to the uh, our project. So text summarization can be defined as shortening long pieces of text by applying computational methods. So basically what happens is you will be given pages of information, and from that pages of information either you have to extract important sentences, or you have to generate new information uh, from those pages. Now, your text summarization can be divided into two types. One is extraction and second one is abstraction. So both the techniques have been explained on the right hand side how they work. So in the first part, extractive summarization technique is explained. So what happens in extractive summarization technique is you will be given a text which will be having n sentences, and after applying computational methods you are going to generate the subset of sentences. Okay, so to generate the subset of sentences you need to uh, perform some steps such as tokenization, then calculate the word frequency, then pick those sentences which have the higher word frequencies, and so on. So basically you will end up in generating only the subsets of sentences. You will not be able to generate the new information. Then next you have abstract to summarization technique. In abstract to summarization technique, what happens is you will be given again n sentences, same information as in case of previous case, but here after applying computational methods you will be able to generate new sentences which may not be just a subset. Okay, you will be able to generate new information. Now if you compare both the methods, extract to summarization technique has the advantage that you can get the results quickly. It is very easy to implement, whereas abstract to summarization is hard to implement, but the results are more closer to the real world. It is not just speaking the few sentences, so it can generate, or it has the ability to generate the new information, which is not possible with extraction. Now the better approach will be to use the merits of both extraction as well as abstraction techniques. So pointer generator network is the method which actually uses the advantages of both extractive summarization technique and abstractive summarization technique. So pointers are generated using extractive summarization technique. We are going to identify the keywords. Then based on these keywords, new information will be generated, which is performed in the abstraction steps. So in our project, we are using pointer generator network method. Now to implement to write this software, the first important challenge was to build a dataset. So dataset was not present, so we built our own dataset. So we visited a few job listing sites like Stack Overflow, Indeed, Naukri.com, and so on. Then we searched for few job postings there, then copied those job postings into a text file. So in that way, we have created the dataset of job postings. Now we also need a data set of syllabus of a few subjects here. The next step, in second step, you have to remove the unwanted stop words, unwanted words, numbers, punctuation marks, and unrelated words, because these will unnecessarily contribute to the speed. Okay, your performance will be affected if you don't remove these things. So that's why you need to remove all the stop words, punctuation marks, and all unrelated words. Then in the third step, you need to tokenize words and sentences. In fourth step, compute the word frequency and sentence score. So here by word frequency, you need to count the uh, frequency of single words, frequency of two words, that is bigram. So then frequency of three consecutive words. Okay, so basically frequency of single words, frequency of two consecutive words, frequency of three consecutive words, and so on. Okay, so when you compute the frequency of consecutive words, actually you are setting a context here, and you are trying to identify different components of a syllabus of a particular domain. The next, select sentences with high scores and concatenate them. Then sort the words in descending order of frequency. So this is important because we have to pick only uh, few words. We need not have to check for all the words. So I can pick only top 10 words, top 20 words, and so on for our comparison. The next, extract the top n words or word combinations from the previous step and compare them with the syllabus of a particular subject. So here we need to use some metrics such as rogue. Then after seventh step, we will be left with two choices. Either refine the syllabus of existing subject with new keywords. If there are only few keywords, then we can consider including them into our syllabus. If there are more keywords, then the software may propose a new subject entirely. Now to implement this, we had used spaCy library, which is industrial strength natural language processing library, which is available in Python, and it's also free and open source library. spaCy is designed specifically for production use and helps you build applications that process and understand large volumes of text. It can be used to build information extraction or natural language understanding systems, or to pre-process text for deep learning. spaCy is not a research software, it's not a platform, it's not an API, it's not a company, it's also not a chatbot engine. If you want more information on spaCy, how to install, and some code examples, then you can visit our website spaCy.io. And Explosion.ai is a company which actually built this spaCy library. They also have two more libraries, Think and Prodigy. So you will find more information on Explosion.ai website. Then spaCy is very beautiful library, and you can have a look at the features. So it offers non-destructive tokenization and named entity recognition. It is supported for more than 61 plus languages, okay, other than English. Right? Then 46 statistical models for 16 languages are available. Then pre-trained word vectors, which will help us to improve the performance, state-of-the-art speed, easy deep learning integration, part of speech tagging. You can identify nouns, pronouns, etc. here. Then labeled dependency parsing, syntax-driven sentence segmentation, built-in visualizers for syntax and NER, that is named entity recognition, convenient string to hash mapping, export to NumPy data arrays, efficient binary serialization, easy model packaging and deployment, then robust, rigorously evaluated accuracy. The recent versions accuracy, that is spaCy 3.x versions accuracy, is around 92%. Then the next library is TextSy, which is built on top of spaCy. So it basically allows us to extend the functionalities of spaCy. So for example, here it is built on the high performance spaCy library. So with the fundamentals, tokenization, part of speech tagging, dependency parsing, etc., delegated to another library, that is all these features are available in spaCy. So TextSy focuses primarily on tasks that come before and follow after. For example, n-gram analysis functionality is not available in spaCy, but it is available in TextSci. So after performing basic tasks using spaCy, you can move to TextSci for n-gram analysis and other advanced features. So you can again refer the specified URL to get the more information on TextSci library. Then next, we can have a look at TextSci features. So you can access spaCy through convenient methods for working with one or many documents and extend its functionality through custom extensions and automatic language identification for applying the right spaCy pipeline for the text. Then download datasets with both text content and metadata. Then easily stream data to and from disk in many common formats. Then clean, normalize, and explore raw text before processing it with spaCy. Then flexibly extract words, n-grams, noun chunks, entities, acronyms, key terms, and other elements of interest from processed documents. Then compare strings, sets, and documents by a variety of similarity metrics. Then tokenize and vectorize documents, then train, interpret, and visualize topic models. Compute a variety of text readability statistics, including flash, kinset, grade level, smog index, and multilingual flash reading ease. Now let's have a look at the source code, what we have written for our experiment. So we need two libraries, one is spaCy and second one is collections. Now on the fourth line, you can see here, there is a set which is nothing but the group of unwanted words which we want to remove. So this set is nothing but the list of unwanted words which are out of context, and we simply don't want them for our processing. Then next, on sixth line, we are loading the English language model, which is a small English language model. There is also a large English language model, but it takes a lot of space. We can experiment with larger model later, and we'll see how it's going to affect our experiment. Then dataset.txt is a file in which the job postings are stored. Then we are going to read the content from dataset.txt. Then apply NLP function to create mydoc object. So basically here we are creating NLP object so that we can perform operations on it. Then for our information, we are trying to print the number of tokens before pre-processing and after pre-processing. So I'll show you in the output how it's going to affect pre-processing. Then on 15th line, we are going to remove, or we are removing the stop words, we are removing the punctuation marks, we are removing the digits, we are removing the white spaces, we are removing the numbers, we are removing URLs and also the emails. Then on 17th line, we are performing lemmatization. So lemmatization is nothing but converting the tokens into their basic form. For example, let us consider the terms player, playing, played, etc. So the root form of all these terms is play. So we are converting all the tokens to their root forms. Again, this will help us to reduce the number of tokens. Then on 19th line, we are converting all our tokens to lowercase letters. Again, it is for better pre-processing. There can be there's a possibility that you may have tokens with mixed cases. Say for example, HTML or CSS. It might be written in CSS, it might be written in uppercase, or it might be written in lowercase. But in computing terms, they will be treated differently. We don't want them to treat them differently. We want them to treat them same. So we are converting them to uniform case. In this case, it is lowercase. Then next, on 21st line, we are removing all the unwanted terms which we have listed in the fourth line. So that is just an indicative list. We have to actually create a huge list of unwanted list. Then next, on 32nd line, we are actually computing the frequency of single words. For this, we are using counter method from the collections. So it is going to generate the list of word frequencies in descending order directly. So you do not have to do much here. Then in 35th line, we are picking top 10 words from the uh, word frequency list. Then in 40th line, we are actually computing the word frequency of two neighboring words. Okay. Then in 43rd line, we are picking top 10 bigrams. In 48th line, we are again computing the word frequency of three neighboring words. That is three consecutive words. And in 51st line, we are picking up top 10 trigrams. Then on 58th line, you can see that there is a statement written syllabus is equal to, so some terms are written. Again, note here that syllabus will also be having stop words and different things. Again, you need to remove, you need to do pre-processing on syllabus content also. So again, this is an indicative list. You can see here that there are few single words and there are few multiple words. That means we have grams and bigrams here. Okay. Then next, on 60th line, we are actually performing the comparison, and we are computing how many words, how many grams are appearing in our syllabus. Then on 63rd line, we are computing how many bigrams are appearing in our syllabus. And similarly on 69th line, we are computing how many trigrams are appearing in our syllabus. So the entire source code repository is available and the URL is specified. You can visit this URL for the source code. Now this is the output. Now you can see here when we run this, first time it is displaying that before pre-processing there are 257 tokens. After pre-processing, you can see here the number of tokens is significantly reduced. It is just 108. So that's why I'm saying pre-processing is very, very important. It is going to affect your performance if you don't pre-process the dataset properly. And it's also displaying the token list after pre-processing. Then next, in the output, you can see word frequency of grams. Now you can see here the counter method is displaying the top words in descending order, that is highest frequency words first and least frequency words last. So you can see here HTML is appearing 7 times, web 5 times, WordPress 4 times, CSS 3 times. So we have to pick top 10 words from this list now. So you can see here it's available on the next line. So top 10 grams, HTML, web, WordPress, CSS, and so on, jQuery, Bootstrap, and so on. And similarly, word frequency of bigrams. So in bigrams also, you can see here that HTML and CSS in combination, they are appearing thrice. Then similarly, web and mobile, they are appearing twice, and so on. Now, similarly, we have to compute, we have to extract top 10 bigrams. After extracting top 10 bigrams, go for word frequency of trigrams, that is 3 consecutive words appearing together. So then after that, extract the top 10 trigrams. Now once it is done, you have to compare it with the syllabus and find out the percentage. Now you can see here when we compare top 10 grams with the syllabus, there are only 5 terms which are matching, and there's only one term, one bigram which is matching with the syllabus. So this is how this project works. Still a lot of work is remaining. We are continuously working on it and we are continuously improving our work. So any suggestions, you can always put it on our GitHub repository. So that will help us to improve this further. Then the conclusion is that to achieve better results using natural language processing, one of the important factor is pre-processing of a document. Using pointer generator network, we can balance the advantages or disadvantages of extractive or abstractive summarization to get the better results. Then need to experiment with the non-professional courses and with other than English language, such as Indic languages, or maybe some other languages also. Thank you.